video, we're going to get familiarized with the software of PATRAN. PATRAN is a CAE, so it's just a user interface, in which you can create a model, set up all the requirements around it, so the pre-processing can all be done in PATRAN in the finite element steps, as we have studied in the theory part, whereas all the processing is carried out by a solver. Now this solver is called Nastran. There are other solvers also that are available for use with PATRAN. So you say, for example, you can also use the Abacus solver after making a model in PATRAN. That's easily possible. But the combination we are going to work with mostly is PATRAN Nastran. Nastran is good enough for linear analysis. So we don't need to look further. Nastran is good enough for all kinds of other analysis as well. But you will see that there are some other options like Mark that are suitable for specific problems, etc., as you would continue working on this in the future. But at this under the current circumstances, we'll just get familiarized with the software. I have to apologize in advance. This is quite an old system. So I have PATRAN 2010, which is installed on this, although we are currently using PATRAN 2014. But the user interface or the way it is set up is absolutely no difference. So I'll just go through all the things step by step very quickly. I don't want to spend a lot of time doing all the details because we will go through them when we are in fact setting up the entire model as the example one. So once you open PATRAN, when you launch it, this is what you see. So of course you have a license file which is coming from some kind of flexible server. Mine is coming from the TU Delft flexible server. This is my computer that is connected and authorized to get this kind of a license. Now what you see here is the window is divided into a few parts. On top you will have the toolbar. Once you have a new model open, a lot more things will show up. Here there are shortcuts for many operations that you can carry out for pre-processing and making all kinds of options to set up the processing step. This is the window or the viewport where you would see all the models, and under it in this section here, this is the message section. So all the messages, every activity that you carry out here will be taking place over here. You can also keep adding some comments by hand here if you know the language that PATRAN is using, which is PCL. You would be able to also type some commands if you would like to on the fly. So in principle, if you have worked with any other finite element software before, you would see that it's very similar to all the others. It's practically the same thing. Also under the hood, there are very minor differences, but it's a matter of choice and license price mostly that defines which one you would be using. So PATRAN Nastran is quite an old one from MSc software, and I have been working with it for a very long time, since my bachelor's, which I completed in 2003. So that's already quite, or 2007, I'm sorry, I started in 2003. So that's already quite some time that I've been working with this user interface, and it has changed and improved tremendously. And needless to say, all the other programs have also progressed in the very same way. So let's get started. I can just go here, file, and open a new file or open an old one, etc. Or I can just go to this shortcut here with all these icons, and I see here the same options which are highlighted. So I'm just going to open a new one. Just before that, you can also see here there are some shortcuts. So if you are in a certain module, it opens up more options over here. So you keep your eye out on what exactly is being shown here. So let's just open a new database. You can also set up which working directory you would be using. By default, it's always in temp. It's not a good folder to work with because most of the time you are setting up problems in temp, and then you will be deleting it, and by mistake it's possible that you lose all that data. So I'm going to change this to this folder called PATRAN, which I have been using for some time now. So I'm just going to make a new database, and I would call it Getting Familiar, because I'm not going to actually save it or anything, but I need to give it a name before I can open one. Now once you open it, this is what your viewport looks like. You can obviously change all the colors, but I'm going to leave it at this because it takes much more time. These are just superficial cosmetic things, and you can learn this on your own by a few searches on Google. It's quite easy. or any other search engine if you prefer not using Google. So you have here on the right, you would see this window which will pop up depending on which stage of the application you're at. So right now you just opened new one, so it says this is a new model preference. So you can choose some preferences for your entire model that will be continued throughout. So you can choose the tolerances, you can also have model dimension. So this is 10, of course, you can make it 200, 400, and that's the sort of grid that it is going to create in your viewport space. The analysis, as I said, there will be a number of solvers that you can use. Among them is also Abacus here. Maybe some of you are familiar with Mark or Dyna or PAMCrash or SAMCEF, and all these are available for use. However, since you are using the student edition or also the limited edition, maybe an older one from the university, not all of them are available to you because, of course, it costs extra money if you want to have more analysis softwares, solvers available to you. So we're going to keep it to MSc Nastran, and the analysis type we know is structural, so we'll keep it there. Although you can obviously have thermal and explicit nonlinear analysis as well. So once you've selected everything here, I'm not going to change this because this is just a matter of taste. I mean, it'll automatically regrid, resize everything if you want later. So you just click OK, and all the settings are ready for working. Again, I apologize in advance. I have to keep using the VPN to connect to the university network. So if this goes off in between, I'll lose my license and hence I cannot save anything. So if it goes off, I will be reconnecting to it by means of my password. So there may be a delay of a few seconds there. Now, when you are in the home section, you see a lot of options, like there are some default options. If you just hover over them, it's going to give you some idea of what it does. This is like resetting graphics. So maybe you moved something and then you have some colors and some fringes and you want to see the wireframe diagram again. You just click on this broom, which also shows up here, and it just sweeps everything clean. You can do all kinds of transformations by means of your mouse. So here you can set up everything, or you can use these transformations for moving any of these the model. But we don't have something here, so it's difficult to show you without something tangible. This is the viewport, so whether you want to zoom into a very small section or you want to fit everything into your full view, etc., can be done here. Here there are different modes of display, orientations for views, or how you want to see. These are standards, of course. You can also have your own views where you can go into particular angles that you want to see it into. You have some miscellaneous options, but I'll let you click on them once in a while to see what they can do for you. Then you have the real pre-processing steps. Like you can see, these 4 over here are all pre-processing steps. Like in every finite element analysis, you're first going to create a geometry, and that's a bit of a down shortcoming for PATRAN because it's not very pretty. So you have to use some kind of older versions of this drawing thing. So you have many different options of making geometries. So you can create points, you can create curves, surfaces, solids, and all these kind of things by providing coordinate lists. And there are certain syntaxes you have to follow with the square brackets, etc. And unless and until you press apply, it's not actually going to carry out what you asked it to do. So you must make sure that after you have selected all the things in this list, you must always hit apply. And sometimes the apply button is actually lower, hidden underneath. You have to make sure you find it and click apply. Otherwise, the options you chose will not be applied to your model. So you can see there are all different kinds of geometric analysis. It's just a drawing tool. You can, of course, draw your models in another software and also import it. That's possible. Sometimes it's allowed in certain particular file formats, so you have to be sure that it can be imported into your particular program. After you've created the geometry, you of course have to provide certain kind of properties to it. You have to apply material so that you can define its stiffness, which is basically nothing but the element behavior. So you go into properties, you will see that there are some options for making materials. So you can have isotropic, orthotropic, anisotropic, composite materials, and you can set up all kinds of material properties here. Whereas after you've set up the material properties, you can make sections or property assignments of a certain kind. So if your model is just a 0 dimension, so like springs and stuff, then you can use this. What if you have 1D springs or beams or bars? You can use all these kind of options. So if you just hover over these, you will see a lot of options. So you have a 2D solid, you have a bending panel, you also have a shell. So there are things you can all use from here, and we will do that in the course during the tutorials and also for the assignments. So this is the part where you are actually defining the element behavior, how it's going to behave, what are the stiffness properties, what is the resistance it's creating, etc. Then you can apply the loads and the boundary conditions. So therefore constraints are therefore very important, as we've discussed. You must have a certain constraint so that your model is not just going to fly away in space. So according to your problem, to create some kind of constraint, it can be displacement based, it can be force based, pressure, something of this kind. So you can see there are different kinds of constraints and loads that can be added. You also have contact between bodies, which we are not going to do in this course because this is a nonlinear problem. You can apply different kinds of initial conditions. So for example, if you have an impact problem and your model is already under certain conditions initially, so a ball is dropping on a flat surface, then you have to give it an initial velocity so that we know that the ball is actually dropping at a certain velocity towards the flat ground. So these are the things that you can explore here for different kinds of constraints and loads. Now, before you create any kind of constraints or loads, you must know that the way PATRAN works is that what you create is always filled into a load case. And there's a possibility of making multiple load cases within the same model. So if I say, okay, there's one particular load case in which I want to have a cantilever beam which has an end load and it's a concentrated load. And that can be my load case concentrated load. But at the same time, I want to also check the results of this analysis when the cantilever beam is loaded under a uniformly distributed load. And in that case, I will create another load case which will be called uniform distributed load. And I can put different loads and different boundary condition sets into both of these load cases. And when I run the analysis, I'll be able to select one of these. So that's quite a neat option here. So within the same analysis, in the same model, you can have different load cases and you can get results for all of them from the same model itself, from the same database file. Once you have set up all the conditions around the model, of course, you have to select what kind of element you want to use, how many elements there have to be. So then you have to come into meshing. So in meshing, you have to go through few steps. The first one is mesh seed. You must decide how many elements you want and where exactly they should be. So there are different ways of doing this. You can have a uniform mesh seed, you can also have biased, you can have curve-based, tabular, and these can either depend on number of elements or the element length. And there's some both options that are available to you. Once you apply the seeds are only possible to be applied on curves or edges. So if you have a 2D surface, for example, just imagine a square plate, then you have to apply the seed on the curves which form the edges of the plate. And then they will be extrapolated to making a grid of elements sort of thing. We will see that in more examples in the near future. But for this little video, we are going to stay away from more details. Then after you've created the mesh seed, you will go into meshing and then you can choose a kind of element. So do you want to use a quad element? Do you want to use, if I have a curve, that means I have a 1D. Do I want a bar element and what kind of bar element I want? There are also different kinds depending on the order of the displacement. Let's say what kind of continuous function you want to use to describe the element behavior. You can also have something on solids and then it changes to tetrahedral or wedges. So there are different options that are possible for the element type as well. And once you have selected the element type, you can also select a certain property which you want to be assigned to this element. But if you have already applied a property to the geometry, you don't need to do this. And once you hit on apply, after selecting over here what you want to mesh, what part of the geometry you want to mesh, you will see that the mesh will be created. With this mesh comes elements. There will be a certain type of elements which you have selected through this option. This element will be of a certain property which you had defined using property types. And these properties will be associated to a certain material which you will be able to pick from one of the materials you've created. So you can verify everything, whether everything has worked correctly or not. I'm going to show this to you through different models as well. So these are all the different options you can carry out for pre-processing. Then you go into processing, which is nothing but analysis. And in the analysis step, You will see that you can have different kinds of analysis. So you can ask for different kinds of output values. You can analyze either the entire model, or you can just check a certain part of the model, etc. And these are options that I would really recommend you to click and see what they are, understand what they mean. There's a lot of documentation available, so if you go through them, you get a much better idea. And under analysis type, you will also see that you have different options here to fill in. Although not all of those will be useful for you, but it's always good to know that it's possible to, for example, pick sub cases, like I said. So if you have different load cases, then you'll be able to pick them up here, ask for particular outputs for every load case separately, and then once you hit apply, it will start running the job. You can always carry out the messages. You can always carry out a check with these messages that keep coming up here, whether what you asked for has been carried out or not. If there's an error, this is where you will see it. It's going to notify you that there's a problem with what you just did. And you can always backtrack and see where it was and how to solve it. Now, once your analysis is done, you can always check your results right here. So you say, okay, I want to, first, after you finish the analysis, you can just say, I want to access the results. And you have different kinds of output files, so you pick the right one. And then you hit apply and you get this particular results file. And within the results section, you'll be able to see all different kinds of options for results. You can see a very quick plot which shows deformation, and the fringe plot for the different stress values, different displacements. You can also see just deformations or just fringes. You can also create graphs within this results section. So it's all possible with different options. So you see that most of the things are quite easy if you follow this setup one by one in this order. Now, apart from all these options, you will also see there are certain preferences that come here. You have display options where you can see a lot more things than what you would get out of these particular options. You can also change viewport. So if you want to have two models in the same window, you can always create another viewport and you can give it a different name, and it can be oriented in a certain way to have a look at things. So they're all different options. Now, one of the best options here is groups, but we're not going to work with them. This is something more for you to understand when you do substructuring. So example, if you have a really large model and you have different parts that are associated to it, then you can easily group it so that you would be able to visualize them separately, also analyze them separately when you need it. So for example, if you have a fuselage structure, then I would make the skin as one group. So all the elements that belong to the skin are going to be put into the group skin. And at the same time, you can have a group which says I want to put all the frames and all the elements that are associated with the frames in the group frame. And this way I can actually separate out the results, I can separate out the visualizations, the geometry, so that I can see them, understand what's going on, and also check results separately. So there are all kinds of options here. You will only discover more and more and more as and when you learn to work with this program and the more number of examples that you carry out. So this is basically your workspace. You have a help option here where you can go into contents and index. What I know about the support from PATRAN Nastran is that it's not as good as the one for Abacus. So you may have to search a little bit more than usual, but there are documentation links that are also provided on Blackboard for you to easily find. And if of course you get stuck, then we are always here. You can put your questions on the discussion board and we can help you solve your problem rather quickly.